Well, hello guys, here Mr. G with another video. This time we're going to be starting with a new topic for the grade 12. We're going to go through some important concepts and definition, and this is about electrodynamics. In grade 11 you already did some of the work. You learned Faraday's law, you learned magnetic field associated with a carrying conductor that is the electricity is flowing. We learned certain things there that is going to be applicable to this specific topic, but we are not going to go into those grade 11 details. We're going to go straight to what is important in grade 12 on how do we apply that electrodynamic from grade 11 into grade 12. We're going to be learning about generators today. We're going to go to each of the two generators if possible, and we're going to be speaking about some uses and example of generators. Okay, now in this case we're going to be starting by a generator. All right, now note the following: the electricity we get at home is coming or is produced most of the time with a generator. AC generator is a device that converts mechanical energy into electrical energy. Generator in general is a device that converts mechanical energy into electrical energy. That is the definition for a generator. That is a generator. And that definition is for sure going to be asked in the exam. Okay, now we are going to have two types of generator, in which one of them is going to be the AC generator. Now, the AC generator means alternated current generator. In other words, the current that is going to be generated by this electrical machine is going to be an AC current. In other words, that current is going to be changing direction. Okay, we later on going to speak more about that specific type of current. But then, if we look carefully here, we have a simple example of a generator. There are important parts you have to learn. The guys is not that difficult. Now, the first important part is the ammeter. Now, the armature of the generator is going to be this specific cable that you see the between the magnet. That one is called armature. Let's fix this word there. It is armature. That is very important. That is going to be that cable that you see there in between the magnet. That one is the armature. Okay, now what is other part of this AC generator is going to be these two rings you see there. Those two rings you see there is going to be called slip rings, and be careful with that one. That one is slip rings. Be careful with the slip rings. That one there is the slip ring. Okay, and that is the one that made the current to change the direction right away here. Okay, now what is the other one? This one here, this one there, which is the same as this one here. I'm going to try to do it like that so you can see it. Those two pieces of the generator, those two parts that is coming out of the ring, this one here, we're talking about that one there, those are going to be the carbon brushes. Carbon brushes. And then the purpose of the carbon brushes is to connect the rings to the external part of the circuit. Okay, that is the main purpose of the carbon brushes. Now note guys, in this question they for sure are going to ask you for parts of a generator, and it's quite simple. And the last one we have to mention here is the poles of the magnet. So this one is poles of magnet or just magnet, and those are obvious, these here as well as this one here. Those are the two poles of the magnet. Guys, this is the part of the generator, quite simple, and then it will be asked to you how to name some part of the generator, specific part of the generator. Now let's see how the generator works. Now what is happening? This is going to be moved. Remember, it's going to convert mechanical energy into electrical energy. So this angle here is going to be rotating. In this case, it's anti-clockwise like that. So that is what you need to know. Somebody is going to be rotating this one anti-clockwise, like moving it by the hand. Okay, that is the main way of working of this generator. Now let's look carefully because it may be tricky there. Now this that you see here, this one that you see here is a voltmeter, or it could be a galvanometer. So let's not get confused by that one. This one is a generator. No, so you see the pole of the magnet, you see the armature that is going to be moving inside the pole of the magnet. In this case, it's moving clockwise. If you look carefully at the arrow, this side of the magnet is going up, and the other side of the magnet is going there, of the armature, pardon, is going down. Okay. Now let's look at the following. Remember, the current is going to be produced, or is going to be generated, induced, because of the change in the magnetic flux. And magnetic flux is the number of lines that is going through that armature. Okay. So remember, there are going to be magnetic flux, magnetic field line that is going from negative to positive in this direction, and they're going to cross past that specific armature. Let's maybe we do it that way. Just see now, you will see it better. There we go. Those are going there, and they pass to all the other way. Okay, and so on. Now, when the armature is in this position relative to the magnet, and look carefully the position in which the armature is relative to the magnet. Okay, there is going to be not, as you can see here, is zero induced EMF. Okay, so at that specific point there is not EMF, because not field lines being cut. There is not change in magnetic flux. Okay, so that is important. In that specific position, the EMF is going to be zero. There is not EMF. Okay, so this is zero voltage, and therefore there is not going to be current also flowing through the conductor. Now let's go to second position. Now second position is when that coil had rotated completely to that specific position that you can see there in the picture. Now remember the lines, but now what happened? But it did cut all of them. That is why you have the maximum voltage. This one will show you the maximum voltage that can be generated from that generator there. So the maximum voltage that can be generated is going to be at that specific point. So if we look quickly at what we have, the step one, it was at zero. Step one was at zero. There was not potential difference or current generated there, as you can see, is zero. Now it go to a maximum value, which is this specific position. So it's going to a maximum value like that. Okay, and let's say for instance this is a step two. When we mention step two, is like the motion, the second part of the motion. It's not exactly like you moving this one in step. Okay, you're moving, rotating the armature. Now remember, at this point, when it passed that point, when it's moving through that point, it did cut all the magnetic field, and that is why the potential difference generated is going to be at the maximum value, the maximum possible value there. Now what is happening? It's going back to the starting position, but on the other direction. So once more, no lines being cut here at this specific point, and then therefore the potential difference is going to zero once more. Let's take this one and move it down with us. Here we are. So with step two, now the step three, what is happening is go back to zero, guys. It's going to go back all the way to zero. There again, we are at zero. And here is going to be step three. Okay, so step three, day one more, we are at zero. Now it keep moving, and when it's in that position once more, which was exactly like position 2, but in the opposite side, then the current is going to be once more at the maximum value, but in the opposite direction. It changed the direction there. So that is important. Let's move this one with us a little bit down so you can see it there. And here we are at this position. So it's going to be once more at the maximum, but on the negative side. So it's going to be like this. And guys, this one is like a sine graph. Okay, so this one at this specific point is going to be step 4. This is like the position in which it's moving. These steps represent the position in which that coil is moving. we're talking at this point there, and then the coil stop as continue moving, and then you start over all the way from step one once more. Okay, so I hope this one is quite clear. This one is a sine graph, but it could be a cosine if the starting point is 0. So this one could actually be a cosine if you're starting from step 2 instead. Okay, so it doesn't really matter where you start moving the graph. So this is the way in which is working this specific generator. When it's in that position, look at the position of the coil relative to the magnet. When it is in that position, the EMF is 0. When it is in this specific position, as you can see, like parallel to the magnet, then the potential difference is going to be at a maximum, and it's very, very important, guys. Okay, so now the generator, we also have something that we call the DC generator. Now, the DC generator is very much like the AC generator. DC means direct current. DC means direct current, okay? Now, the DC generator is very much the same as the other one. The only difference is that the slab ring is going to be changed for a split. Let's fix this word. Is split ring commutator. If you think you're going to get confused, you can just use the word commutator there. Okay, it is here. Now, which one is the split ring commutator, guys? Is that one there. We change, the only change is made to make a AC generator a DC generator. You replace that slab ring with the split ring, and now you have a DC commutator. And this is the same principle as it is moving. Then that one will be generating, changing the magnetic flux in the mixture, and therefore it is going to be not changing direction of the current. So the purpose of this split ring commutator is to keep the current in one direction. You can see that it is cut at this specific point. So when the current go there and is at 0 point, for instance, instead of changing direction, go back to maximum within the same direction, if we could say same direction. And so the graph in this case will look like this one in the position. So if we go back to the steps 1, 2, 3, and 4, as you can see, here is step 1 is when you start with the position and that specific, I may say, vertical position or maybe perpendicular position to the magnetic field. This one here, this one is step 1. You start from 0. It goes to a maximum value still, that is when the horizontal position, that will be like step 2, and then it's going to step 1 again, or step 3, but instead of changing direction, it's go back to the maximum in the same direction. Okay, why? Because of the commutator. The commutator, or the split ring commutator, is responsible to keep the current to be a direct current. Okay, now something important is how to determine the direction in which the current is flowing, or in which the generator is rotating, and that is going to be using the right hand rule. Remember, the right hand rule is not a law, it is a rule. Okay, so different people, different teachers will use the rule differently. Now, the one I like is this one. Eventually we're going to speak why I like this one, but not now. So in this case, the thumb is going to indicate the motion of force, the motion in which the commutator or the generator, is going to be moving. Now the pointing finger is going to represent the magnetic field, and the rest of the finger, or the middle finger, is going to represent the induced current. It's quite simple. Now this one, guys, you must not stress, this one is 1 mark in the exam. Is going to be 1 mark. It should not be more than 1 mark. So it's not something to really worry about. However, it's important. It's important. You must try to get full marks. Okay. Now let's move on. We'll go back to the right hand rule when to do a question. Application of generator. Okay, this is how and where do we apply generators. It's quite important This is important because as you identify the direction of the current 1 mark, this one could be up to 2 or 3 marks, or 3 marks, depend the question. They say give 1, give 2, give 3 application of a generator. And now, what does affect the generator? Very important. First of all, how can we improve the generator? By improving the generator, what we want is to generate a greater potential different EMF and therefore current. So first, the magnetic field strength. If you increase the strength of the magnet, or you change the magnet for stronger magnet, there will be more EMF produced. Second, speed of cutting. It means if you rotate the generator faster, you will be cutting more flux or more magnetic field lines per unit time, therefore more EMF produced. And the other thing is number of pieces of wire, number of coils. Now, number of coils is referred to the number of coils in the armature. If you have more coils in the armature, then we'll also have a greater potential difference and so on. Okay, now this one is coming from the Faraday's law. If you remember the equation, let's just write it here. You are not going to use it, I think, but here in this equation you will have, and you will see the relation. The strength of the magnetic field have to do with the how strong the magnetic is, but this one is the rate at which magnetic flux is changing. This one is a factor number, let me see, factor number speed of cutting. That one is this factor, the how speed, how the rate you increase or decrease, and n represent the number of wires. So this is quite important. Okay, so I hope it helped. Now, activity 1, I don't know if we'll have, let's go quickly. The given diagram shows the basic principle for an operator of a generator. As you can see here, if you look carefully, this one is a DC generator. So without reading further on, this one here is a DC generator. DC generator. How do I know that? Because you have here only one ring which is cut, and that is the split ring, because it has a split ring or commutator. Okay, that is why this is a DC generator. I already know that before I even go on reading. What type of generator is this one? That one is the answer for that specific question. So we just answer here question 1.1. Name the type of energy conversion that take place in the generator. Another very easy mark, guys. All generators convert energy from mechanical, what is that line, to electrical. So the energy conversion is from mechanical energy to electrical energy. The name of the parts label X, Y, and Z. So Y here you can see is this little one, okay, and that is the carbon brushes. So the Y, I'm going to write it here, is carbon brushes. Then we have Z. We already spoke about Z. Z is the ring, and then we can say that Z is the split ring. You can also write a commutator and it will be fine. And X, which is the last one we look here, is, guys, the armature. So X is the armature. Okay, so now state two methods to increase the induced EMF. Guys, we just mentioned that one. It is right here. By changing the magnets for stronger ones, by moving faster the generator, by rotating faster, or by increasing the number of wire in the armature there. Okay, how do DC and AC generator differ? It is the different from you can say DC has a split ring, and the AC has slip rings. Yay, rings. Okay, there we go. That is the difference between the two of them. And write down two examples of the uses of generator. Guys, I'm not going to write it. It is all here. Where do we use generators? Just stop the video, write the examples, because in the exam they're going to ask you. Guys, this is the video, the first lesson of electrodynamics. I'm sorry it went a little bit longer. Next time we may do 1 or 2 questions on this topic, and then we go to electric motors. Thank you for watching. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.